Good evening, children.
Good evening, ma'am.
Good evening.
Ma'am. Good evening, ma'am.
Good evening, children. Tanya, Madhumita, Netra, and Srijana. So we were discussing in the last class, we were discussing about a linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial. So this way of naming polynomials is based on the degree, of the polynomial. So when the degree of the polynomial is 1, we call it a linear polynomial. When the degree of the polynomial is 2, we call it a quadratic polynomial. When the degree is 3, we call it a cubic polynomial. And when the degree is 4, we call it a biquadratic polynomial. So these names are based on the degree of the polynomial. We also have monomial. We also have classification of polynomials based on the number of terms. We also have classification of polynomials based on the number of terms they bear. So a monomial, as you all know, is a polynomial with one non-zero term. Binomial, 2 terms. So 2 terms you should understand, 2 non-zero terms. Monomial, binomial, trinomial. So we finished all this, and we were talking about, we were just about to start, what a constant polynomial is. Constant polynomial. So we have to continue from here. What is a constant polynomial? So before that, we understood that a monomial is a polynomial with one non-zero term. A binomial is a polynomial with 2 non-zero terms. A trinomial is a polynomial with 3 non-zero terms. Like, for example, 3x plus 7x plus 11x is not a trinomial. So I've told you, and you also know that you have to simplify before you conclude what type of polynomial it is. So 3x plus 7x plus 11x can be simplified to 21x. You can add them up and it's 21x, and 21x is a monomial. 21x is a monomial. You should not just count 1, 2, 3 terms, so it's a trinomial. Again, if you have 21x plus 0, this is not a binomial because this is a 0 term. 2 non-zero terms, this is a 0 term, this is 0. So 21x plus 0 is not a binomial. So you just have to remove this, and there's only one term. It's a monomial. All right. Now, what is a constant polynomial? What is a constant polynomial? I think you have the definition with you. So every non-zero, I think you already have it. Every non-zero real number is a constant polynomial. Every real number other than 0 is a constant polynomial. So you can give many examples. Now root 5 is a constant polynomial. Root 5, it's a real number. It's not 0. So it's a constant polynomial. Root 5 is a real number. It's not 0. It's something other than 0. So it's a non-zero real number. It's a constant polynomial. Now, what about the degree? What about the degree of root 5? So the degree is defined, or the degree is decided based on the power of the variable involved. Now, root 5 can be expressed as root 5 x to the power 0. See, when there is no variable attached, to root 5. There is no variable attached to root 5. Okay, let's just take this example. So now when we say 3x square minus 4x plus 5. So how do we say plus 5? How do we say that this is a quadratic, it's a quadratic polynomial? How do you say it's quadratic? Because the highest power of the variable is 2. In this term, the power of the variable is 2. In this term, the power of the variable is 2. In this term, the power of the variable is 1. The power of the variable x is 1. And here, it's like x to the power 0. You can just ignore the constant. So in case you want to write the power of the variable, it is x to the power 0, because you know x to the power 0 is 1. X to the power 0 is 1, and 5x to the power 0, meaning 5 into 1, which is 5. Which is 5. So you can just look at 5 as 5x to the power 0. X to the power 0, which is nothing but 5. So here the power is 0. And the highest power, 2, 1, 0. The highest power is 2. So we call it a quadratic polynomial in one variable x. Quadratic because the highest power is 2. The powers are 2, 1, and 0. The highest power is 2. So the degree of the polynomial is 2. And since the highest power is 2 and the degree is 2, it's called a quadratic polynomial in one variable x. In one variable x. And if you want to classify it based on the number of terms it has, if you want to classify it based on the number of terms it has, it's a trinomial. It's a trinomial. If you want to classify the same polynomial based on the number of terms, it's a trinomial. 1, 2, 3. It's a trinomial. Based on degree, it is a quadratic polynomial. Based on degree, it is a quadratic polynomial. So now when it is simply root 5, you can write root 5 as root 5 x to the power 0 or root 5 y to the power 0. Just use a variable and raise it to the power 0. Just use any variable and raise it to the power 0. So you can write root 5 as root 5 y to the power 0. Any variable, use any variable. So root 5 z to the power 0. You have to raise the variable to the power 0 because anything raised to the power 0 is 1. And you're not changing the value now. It's still root 5. Though you write it as root 5 z to the power 0, z to the power 0 is 1. And root 5 into 1 is root 5. So you're not changing the value of the, the constant polynomial root 5. You cannot add or take away something and change the value of the expression given. So you can do anything without changing its value. So though we write z to the power 0, it is still the value of the expression given. It's still root 5. It doesn't change. And you can see that the variable is raised to the power 0. Now you cannot write root 5. You cannot write root 5 as root 5z. Because that is root 5z. That is root 5z. Z means power 1. It becomes a linear polynomial. You cannot write root 5, meaning I'm not saying, okay, I shouldn't say you cannot write. I must say that root 5 is not the same as root 5 y square. Root 5 is not the same as root 5 y square. Root 5 y square is different. This is a quadratic polynomial. This one is a quadratic polynomial in one variable y. And it's also a monomial. Root 5 y square is a monomial. Only one term. It's a monomial. Based on the number of terms, it's a monomial. And based on the degree, it's a quadratic polynomial. So root 5 cannot be written as root 5 y square. Root 5 cannot be written as root 5 y square. So the only way of writing root 5 is root 5 any variable raised to the power 0. So say x to the power 0. So what's the power of x? 0. So the degree of a constant polynomial is 0. Because what decides the degree? The power of the variable, the highest power. If there are many terms, then you have to consider the powers of all the terms, and then the highest power. The highest power is the degree. So here 0, the power of x is 0, and that is the highest power. So conclusion, degree of a constant polynomial is 0. Degree of a constant polynomial is 0. That's what is the conclusion. So root 5 is an example of a constant polynomial. And root 5 can only be written as root 5, any variable raised to the power 0. That's just for you to understand. So root 5 can be written as root 5, say a to the power 0, variable a to the power 0. A to the power 0 is 1, and root 5 into 1 is root 5. So the variable is raised to the power 0. So the degree of root 5 is 0, or the degree of a constant polynomial. Degree of a constant polynomial is 0, Yeah, make a note of it. Just wait for 1 minute. Make a note of whatever you want from the screen.
Completed, ma'am.
Got it.
Completed, ma'am.
Got it.
Completed, ma'am.
Completed, ma'am.
I'll let you know. So this is about a constant polynomial.
Completed, ma'am.
All right, good. So now let's also look into the, the zeros of a polynomial. Okay. Now to understand that, can I clear the screen?
Yes, ma'am.
All right.
Yes.
Okay, let me finish a zero polynomial and then talk about the zeros of different polynomials. So now finally we have, so after linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, we have constant polynomial and then zero polynomial. I also told you this yesterday. Zero is the only zero polynomial. There are no examples. Zero is called the zero polynomial. Zero is called the zero polynomial. The zero polynomial. Zero is called the zero polynomial. So there's nothing like example. Zero, only zero is called the zero polynomial. Now, what is the degree? What's the degree of zero? Or what is the degree of a zero polynomial? What is the degree of a zero polynomial? Now, 0 can be written as 0x to the power 0. You can also write 0 as 0y to the power 2. You can write 0 as 0z to the power 4, because z to the power 4 is z to the power 4. Into 0 is 0. Now, consider all the three cases. 0x to the power 0. What is x to the power 0? 1. And what is 1 into 0 is 0. Okay, 0y square. Y square into 0. Y square into 0 is 0. Okay, 0 z to the power 4. Z to the power, because when you say 0 z to the power 4, it is 0 into z to the power 4. So 0 z to the power 4. See, now to understand or to find the degree of a polynomial, we need a variable. So we introduce variables like x, y, z. You can go on like this. So you can write 0. 0 can be written in many ways. So I've just shown three of them. So 0 can be written as 0x to the power 0, 0y square. In all the cases, it means 0 into x to the power 0 or 0 into y square, 0 into z to the power 4. Now, when you present 0 in different ways like this, is the value still 0 is what we are checking. When you write 0 as 0x to the power 0, is it still 0? Here also, is it still 0? Because you shouldn't change the value. You can make it look different, but you shouldn't change its value. It should still be 0. So you can write 0 like this. You can write 0 like this. But so, okay, so we have written 0 like this, but is the value still 0 is what we're trying to check. So what is 0? Y square into 0. What is y square into 0? 0. What is z to the power 4 into 0? 0. So you can write 0 as 0x to the power 100. 0, okay, y to the power whatever, like 215. So now from this, when you write 0 like this, children, please watch what I'm marking. If you write 0 like this, you will say that the degree of 0 is 0. From the power of the variable, you will say that See, okay, so you should have understood that you can express 0 in many ways. Now, when we took up root 5 can be expressed with any variable raised to the power 0 only. So the degree of a constant polynomial is 0. When we took the example of root 5, we said the degree of a constant polynomial is 0. How did we come to that conclusion? Because alongside root 5, you can introduce any variable, x, y, z, any variable, but raised to the power 0 only. A to the power 0 only. Then only a to the power 0 is 1, and 1 into root 5 is root 5. You're not changing the value. So clearly the degree of a constant polynomial is 0. The power of the variable is 0, so the degree of a constant polynomial is 0. When it comes to the 0 polynomial and its degree, you can see that 0 can be written in so many ways. So from this, we say the degree is 0. From this, we say the degree is 2. The degree is 2 because the variable is y. The variable is y. Its power is 2. See, 0y square is also 0. We have not changed the value. It is 0 only. So now who will decide the degree? The power of the variable. What is the variable y? What is its power 2? So then its degree is 2. Then from this, what's the conclusion? The variable is z. The variable is z. And what is the power? 4. So the degree is 4. Here, this is also 0. The value is 0 because anything into 0 is 0. This is also 0. So you can write 0 in so many ways. And from different ways, you'll get different degrees. And here, what does this one say? What does this one say? The variable is x. Its power is 100. So that means the degree of 0 is 100. What does this one say? The variable is y and its power is 250. So this says that the degree of 0 is 250. Now see, degree is one answer. What is your name is one answer. You can have a pet name, but disregarding that one, you have one name. What is the name of your school? There's only one name. Like that, degree, you must give one answer. You cannot say degree is 0, degree is 1, degree is 2, degree is 3, degree is 100. No, you cannot give so many answers. What is the degree of a 0 polynomial? Should be one answer. One unique answer. Meaning all of us should say the same answer. If all of us can give different answers, we say that the degree is not defined. We say that the degree is not defined. It's not defined. You can't say because it's not unique. So from this, one of you says 0. From this one of you say 2. I say 4. Somebody says 100. Somebody says 250. All of us have different answers. But the answer should be unique. The answer should be unique, meaning all of us should have the same answer. It is not so. So we say that the degree of a 0 polynomial is not defined. Is not defined. Not defined because it is not a unique answer. So conclusion, if you want to write out something from the screen, I'll just wait for some time before I erase it. Please write now, children. When I give you time to write, please write. Don't take screenshots. You can take screenshots, but make sure you write and take a screenshot. Don't postpone when you're given time to finish it in the class. Lecture. Can I clear the screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Yeah. Somebody wants me to wait?
No, ma'am.
Okay. All right. So now, so the degree of the 0 polynomial is not defined. It's not defined. is not defined. This is the conclusion. The degree of the zero polynomial is not defined. Yeah. So now we have spoken about classification of polynomials. Classification of polynomials based on the number of terms. Based on the number of terms. 1 term monomial, 2 terms binomial, 3 terms trinomial. And we also have classified polynomials based on their degree. Linear, degree 1, quadratic, degree 2, cubic, degree 3, constant polynomial, degree 0, zero polynomial, degree not defined. So this is what we've seen so far. Now, everything is important, but this is even more important. The zeros or the we say zeros of a polynomial, roots of an equation, but mostly the term zero and roots are, used interchangeably. When we say zero, zero is used with respect to a polynomial. Roots, the term root or roots is used with respect to an equation. Like we say linear polynomial, linear equation. Quadratic polynomial, quadratic equation. Cubic polynomial, cubic equation. So we say the zeros of a quadratic polynomial, the roots of a quadratic equation. The zeros of a cubic polynomial, the roots of a cubic equation. It's like that. So the term zeros are used with polynomials and the term roots, let me write that, are used with equations. So like whatever polynomial equation. Okay. So we say like zeros of a, just for example, just for you to understand the usage. So zeros of a cubic polynomial, roots of a cubic equation, roots of a cubic equation. Sorry. Roots of a cubic equation. What's a cubic equation? When you equate it to 0, like if you have x cubed plus 5, this is a cubic polynomial. When you equate it to 0, it's a cubic equation, that's all. Now, when you write x squared minus x plus 4, this is a quadratic polynomial. When you equate it to 0, it's a quadratic equation, that's all. When you equate the polynomial to 0, it's an equation. If it's a linear polynomial, like 5x plus 4, is a linear polynomial. When you equate it to 0, it's called a linear equation. Linear polynomial is called a linear equation when you equate the polynomial to 0. Equate it to 0 meaning when you say is equal to 0, equating it to 0. So we say zeros of a cubic polynomial, roots of a cubic equation, but these terms are used interchangeably. But this is the difference, like when to use zeros, when to use roots. We use zeros when we are referring to polynomials. We say roots when we are referring to equations. Yeah, now this part is not actually very clear because I'm still to tell you what zeros are. So now I'll use zeros and roots interchangeably. You know the difference. Even in books, it will be used like that, which is why even I want you to get used to that. All right, children, can I clear the slide?
Yes, ma'am.
All right. Now, I'll just take very simple examples to make you understand what zeros or, okay, let me say zeros, okay? So what zeros are, okay? Now, we say that a linear polynomial, number of zeros. Degree we understood. Degree 1, degree 2, degree 3, degree 0, degree not defined, all that we understood. Degree can be degree 0 for a constant polynomial. Degree is not defined for a zero polynomial, for the zero polynomial. Now we are talking about the zeros of a polynomial. We understood what degree of a polynomial is. Now we're trying to understand what zeros of a polynomial are. Zeros. So polynomial and zeros, or number of zeros. Number of zeros. So a linear polynomial has at most, meaning a maximum of 1 0, only 1 0. We'll understand what this means, okay? A linear polynomial has only 1 0. A linear polynomial has at most 1 0. Now, what is the meaning of that? Now, for example, 4x minus 5. Is this a linear polynomial, children? Is this a linear polynomial, 4x minus 5?
Yes, ma'am.
Okay, now how do we find the zero? How do we find the zero of this polynomial? How do we find the zero of this polynomial? Equate it to 0, meaning you solve it. Equate it to 0 and solve it. So you get 4x is equal to 5, x is equal to 5 by 4, x is equal to 5 by 4. Now we say that 5 by 4 is the only zero. We say that 5 by 4 is the only zero, is the one and only zero of this linear polynomial 4x minus 5. What is the meaning of that? That means in place of x, when we use 5 by 4, the equation is satisfied. When in place of x, we use 5 by 4, what do you get? You get 0. 4 gets cancelled, 5 minus 5, we get 0. The answer is 0. If you get the answer as 0, that means that value is a 0 of the given polynomial. I'll tell you again. I'll tell you the same thing. You're given a linear polynomial. To find its 0, you have to equate it to 0. So we considered the linear polynomial 4x minus 5. This is a linear polynomial. We are trying to find the 0 of this linear polynomial. For that, you'll have to equate it to 0. You'll have to equate it to 0 and solve. So 4x is equal to 5, x is equal to 5 by 4. Okay. Now, what is 5 by 4? 5 by 4 is called the 0, the one and only 0 of the linear polynomial 4x minus 5. The zeros of different polynomials will be different. For different polynomials, zeros are different. Now, for this polynomial 4x minus 5, 5 by 4 is the only 0. What is that only 0? What do we mean by 0? What do we mean by a 0? So 0 or zeros is or are those values that satisfy the linear equation or which makes the value of the polynomial 0. Suppose you use that value in place of the variable x or variable y, and the value of the polynomial becomes 0. Then that value which you substituted in place of the variable is called the 0 of the whatever polynomial, linear polynomial or whatever. So now we got x is equal to 5 by 4. Now the linear polynomial is 4x minus 5. In place of x, we're going to use the value 5 by 4. So 4 into 5 by 4. Minus 5. What happens when you use 5 by 4? The value of the polynomial becomes 0. See here, 4 and 4 gets cancelled. 5 minus 5. The value of the polynomial becomes 0. When you use in place of x, when you use this value 5 by 4, the value of the polynomial, the value of 4x minus 5 becomes 0. When the value becomes 0, then this 5 by 4 is called a 0 of this linear polynomial 4x minus 5. Now let's use some other value in place of x. Let's use some other value in place of 4, in place of x, in 4x minus 5. In place of x, we'll use some other value, say like minus, whatever you want, so like say minus 3, minus 5. In place of x, we use minus 3, minus 5. We get minus 12, minus 5, minus 17. It's not 0. It's not 0. The value of the polynomial is not 0. So that means minus 3 is not a 0. Minus 3 is not a 0 of 4x minus 5. In fact, as we have understood, a linear polynomial has a maximum of 1 0. It has only 1 0. A linear polynomial has 1 0. In fact, it is 1 and only 1 0. and that 0, 4x minus 5. And that 0 for 4x minus 5 is 5 by 4. So like this, if you take 2x minus 12, again, okay, 2y minus 12. 2y minus 12 is again a linear polynomial. 2y minus 12 is again a linear polynomial in variable y. In variable y. So to find the zero, we know that a linear polynomial has 1, 0. And to find the 0, we need to equate the polynomial to 0. We need to equate it to 0. So 2y is equal to 12, y is equal to 12 by 2, y is equal to 6. That means in the linear polynomial 2y minus 12, in place of y, when you use 6, the value of the polynomial will be 0. The value of the polynomial will be 0. So in place of y, when we use 6, the value of 2y minus 12 becomes a 0. So 6 is called a 0 of the polynomial 2, not a 0, the 0. So 6 is called the 0 of the polynomial 2y minus 12. And that's the only 0. No other value for y. You give some other value for y, the value of the polynomial will not be 0. You give some different value for y other than 6. Only 6. Only this number 6 will make the value of 2y minus 12 0. Will make the value of the polynomial 2y minus 12 0. For y other than 6, you give any other value, the value of 2y minus 12 will not be 0. So 6 is the only 0 of 2y minus 12. Because in place of the variable y, when you use 6, the value of the polynomial is 0. Now, next, under the same thing is quadratic. That is the type of polynomial is quadratic, and the number of zeros is maximum 2, at most 2 zeros. At most 2 zeros. At most, again, if you don't know the meaning of the term at most 2 zeros, meaning it can have no zeros, 1 0, or maximum 2 zeros. That is the quadratic polynomial may have no zeros. Now, for example, if you take the quadratic polynomial x squared plus 64, if you take the quadratic polynomial x squared plus 64, there is no value for x. There is no real value. There is no real value for x, which can make the value of this polynomial 0. There is no real value of x. Because we know there are imaginary values also. We are talking only about real values. There is no rational or irrational value. That is what we mean by real values. Real numbers are rational and irrational numbers put together. So there is no real value for x, which can make the value of this polynomial 0. That is, for x, you use whatever value. The value of the polynomial will not be 0. Just 1 minute, children. Yes, children, I'm back. So there is no value for x. This is a quadratic polynomial. There is no value for x, which can make the value of this polynomial 0. Now we have plus 64 here. That means this one should become minus 64. This one should become minus 64, right? If the value of this polynomial should become 0, if the value of the polynomial should be 0, then what should be the value of meaning we have plus 64. The other thing is x squared. So x squared should be minus 64. X squared should be minus 64. This one should become minus 64. How will you get minus 64? When you use 8, say supposing you say x is 8. 8 squared plus 64 is 6. No, like I'm saying in place of x. in place of x, if you use 8, what will you get? 8 squared plus 64. So 64 plus 64 is 128. It's not 0. So that means 8 is not a 0 of x squared plus 64. Supposing we use minus 8, we use minus 8. So what happens? X squared, what happens? X squared plus 64. If you use minus 8 the whole square plus 64. But we know that minus 8 into minus 8 is not minus 64. It is plus 64. Plus 64, again 128. There is no value for x. There is no value for x which can make the value of this quadratic. This is not the only example. There are many examples like this. So you can just remember like this. You use a variable like y square and use a perfect square number here. Plus, not minus. You must use plus a perfect square number like 100. Like 100. So you must have written down that a quadratic polynomial has at most 2 zeros. At most 2 zeros meaning? At most 2 zeros meaning no zero at all. That is, there is no value of x. There is no value of x which can make the value of the polynomial 0. So in the case of x squared plus 64, whatever value x takes, whether x takes 8 or minus 8 or any other value, the value of x squared plus 64, the polynomial x squared plus 64 will not be 0. It should be 0. Only then you can find the zeros. No, it won't be 0. For whatever value of x, x squared plus 64 will not be 0. That means there is no 0. X squared plus 64 has no zeros. This is an example of a quadratic polynomial with no zeros. Let's take an example of a quadratic polynomial with 1 0, exactly 1 0. So I said you can, example here can be z squared plus a perfect square number like 144, not minus, plus. You can remember like that. Yeah, in some time I'm going to clear the slide. Okay, now we're going to see an example of a quadratic polynomial with exactly 1 0. With exactly 1 0. Now, for example, x squared minus 6x plus 9. Okay, so now when you factorize this, now how do we? I told you, how do we find the value of the 0? How do you find the zeros of a polynomial? You'll have to equate it to 0. Like the first one I told you. Okay, the earlier example, I said x squared plus 64, right? When you equate it to 0, what is that you get? X squared is equal to minus 64. So x is equal to square root of minus 64. And you know that there is no real value for this. Square root of a negative number does not exist. That is, there is no real value. It's imaginary. How do we find the zeros? When it was a linear polynomial, 4x minus 5, I think was the example. How to find the 0? We'll have to equate the polynomial to 0. To find the 0, you'll have to equate it to 0. And on solving, we got x is equal to 5 by 4. And we concluded that 5 by 4 is the 0 of 4x minus 5. So the next example, when you equate it to 0, you get x squared is equal to minus 64. X is equal to square root of minus 64. The value of x is the square root of minus 64. And we know that the square root of a negative number does not exist. It's an imaginary value. It's not, there is no real value for this, for this expression. Square root of a negative number does not exist. Does not exist meaning it is not real. It's imaginary. So that's what I said. Since there is no real value for this one, x squared plus 64, the quadratic polynomial x squared plus 64 has no real zeros. No real zeros. Or simply no zeros. Because there is no value for x. There is no value for x which can make x squared plus 64 0. Which can make the value of x squared plus 64 0. So now again, to find the zeros, we'll have to equate the polynomial to 0. So now this is again a quadratic polynomial. This is again a quadratic polynomial. To find the zeros, we'll have to equate to 0. So how do you solve this? You'll have to solve it basically. We'll have to solve it. See, that's what we did with 4x minus 5 is equal to 0. What did we do? We solved for x. We solved it for x. Do the same thing here. Solve it. How do you solve for x? You have to split the middle term. You'll have to split the middle term. So when you split the middle term, it's going to be x squared minus 3x plus 9. You can also use the formula. You can also use the formula a squared minus 2ab plus b squared. I'm just splitting the middle term. So you get x minus 3 into x minus 3. See, these things you already know. So I'm not fast because you already know it. So now we get this is equal to 0. And how do you find the zeros? X minus 3, equate each of the factor to 0. X is equal to 3. X minus 3 is equal to 0. X is equal to 3. You're getting the same answer in both the cases. You're getting the same answer in both the cases. X is 3 in both the cases. That means this quadratic polynomial has only one 0. That means this quadratic polynomial has only one 0 because both the values of x is 3. So that doesn't make it two zeros. That doesn't make it two zeros. So x is equal to 3, which means this quadratic polynomial has only one 0. It can have a quadratic polynomial can have a maximum of two zeros. A quadratic polynomial has at most two zeros. That means it may not have any 0. No zeros, 1 0, 2 zeros. No zeros, 1 0, 2 zeros. Maximum 2 zeros only. So we saw an example where the quadratic polynomial does not have a 0 at all. This is an example where the quadratic polynomial has only one 0. That means what? 1 0 means what? In x squared minus 6x plus 9, in place of x use 3. In place of x use 3. So 3 squared minus 6 into 3 plus 9. So what's this? 9 minus 18 plus 9. So 9 plus 9, 18. 18 minus 18 is 0. So only when x is 3, the value of the polynomial is 0. The polynomial is x squared minus 6x plus 9. It's a quadratic polynomial. We are trying to find its zeros. For that, we need to equate the polynomial to 0. We need to simplify or solve the polynomial for x. Solve the equation for x. We solved it by splitting the middle term. Then we got two factors, x minus 3, x minus 3. Equate them to 0. So x is equal to 3. X is 3. Now in the polynomial x squared minus 6x plus 9, in place of x use 3. In place of x use 3. What's the value of the polynomial? 0. Now use some other value for x. The value of the polynomial will not be 0. You'll get some other value. It will not be 0. Only 3 can make the value of the polynomial 0. Only 3. Only when x is 3, the value of x squared minus 6x plus 9 can be 0. So 3 is the only 0 of the polynomial x squared minus 6x plus 9. So here the example can be any perfect square. Now this one is a perfect square. You don't have to remember so much. I'm just telling you. So x minus 3, they'll not ask you to give examples. We're just trying to understand. So every perfect square will can be an example. Now this one is a perfect square because see both the factors are the same. X minus 3, x minus 3. So x minus 3 the whole square. It's okay if you don't understand this part. Now another example where a quadratic polynomial has two zeros. This is okay?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Sorry. Yes. Yeah. Thank you. So now supposing I say x squared minus 5x and plus 4. Okay. This again is a quadratic polynomial. This one is a quadratic polynomial. X squared minus 5x plus 4 is a quadratic polynomial. Now to find its zeros, so we know theoretically we know that a quadratic polynomial has a maximum of or can have at most two zeros. A quadratic polynomial, I'm repeating. So a quadratic polynomial has at most two zeros. That means it may not have any 0 or it can have only 1 0 or 2 zeros, maximum 2 zeros. So this is an example. This one is an example of a quadratic polynomial with two zeros. So how do we find the zeros? Equate it to 0 and solve it by splitting the middle term. So x square minus 4x minus x plus 4 is equal to 0. The product is 4 and the sum is minus 5. So we split the middle term, x into x minus 4 minus 1 into x minus 4 is equal to 0. So x minus 1 into x minus 4 is equal to 0. Even maybe you don't have to equate it to 0 here. See, like you can also equate it to 0 here. You can just split the middle term, as you all know. You can also do it like this. So you know how to split the middle term. So you split the middle term, equate each of the factor to 0. Equate each of the factor to 0. So x is equal to 1. Then x minus 4 is equal to 0. X is equal to 4. So we got two different numbers. So these two numbers, 1 and 4, can make the value of x square minus 5x plus 4 0. Now let's check that. X square minus 5x plus 4. Now in place of x, we'll use 1. In place of x, we will use 1 in place of x. So that makes it like this. 4 plus 1 is 5. 5 minus 5, 0. So when x is 1, the value of x square minus 5x plus 4 is 0. So 1 is a 0 of the polynomial x square minus 5x plus 4. Let's try the other one. When x is 4, can I just change it here itself? I'll just change it to 4 here. So when x is 4, okay, I'm changing it here itself. When x is 4, okay, when x is 4, 16 minus 20 plus 4. So 20 minus 20. 20 minus 20 is 0. Now, other than 1 and 4, you give any other value for x. Other than 1 and 4, you give some other value, say minus 1, minus 4, 2, 3, whatever. The value of the polynomial will not be 0. Other than 1 and 4, for this polynomial, for x square minus 5x plus 4, other than 1 and 4, you give some other value for x. The value of the polynomial will not be 0. Only when x is 1 or x is 4, the value of x square minus 5x plus 4 will be 0. For no other value of x square minus 5x plus 4, the value of this polynomial will be 0. So this is an example where a quadratic polynomial has two zeros. And since a quadratic polynomial has a maximum of 2 factors, cannot have more than more than 2 zeros. Are we getting an idea about zeros of a polynomial? So zeros of a polynomial are those values that make the value of the polynomial 0. If you call a number the zero of a polynomial, that means in the polynomial, in place of the variable, when you use that value, the value of the polynomial itself will be 0. Understood, children, what zeros of a polynomial are?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, so now so much of detail, meaning working with examples is not needed for you. Now we can work cubic polynomials, but it's only going to take your time. So this is what it is. Now a cubic polynomial has a maximum of 3 zeros. It has a maximum of 3 zeros. A cubic polynomial can have a maximum of 3 zeros. It's important to understand the zeros of a constant and a zero polynomial. Let's do that. Linear polynomial 1 0, quadratic at maximum 2 zeros. That means it may not have a 0. It can have 1 0 or maximum 2 zeros. Cubic polynomial 3 zeros. We'll not take examples and spend time. So now we'll move on to constant polynomial and zero polynomial. Constant polynomial and zero polynomial. We'll understand the number of zeros a constant polynomial has. Constant polynomial, number of zeros. We're trying to understand how many zeros a constant polynomial has. Now, I'm just telling you, I'll write the result, but we'll just take an example. Now, you know that 3 is a constant polynomial. 3 is a constant polynomial. Now, to find the zeros, you need a variable, right? Now, before that, you need a variable. So you can write 3 as 3x to the power 0. 3 is 3x to the power 0. That is why the degree of a constant polynomial is 0. That's why the degree of a constant polynomial is 0. Now to find the zeros of this constant polynomial, we'll use some value for x. 3. Now supposing x is 1. Supposing x takes the value 1. 1 to the power 0. Anything to the power 0 is 1. And 1 into 3 is 3 only. So now please think about it. Whatever value you give for x. See, I think I'll just come slowly again. Still very slowly. Now 3 can be written as 3, any variable, x, y, z, anything to the power 0 only. Because x to the power 0 is 1 and 1 into 3 is only 3. If you simply write x, it will become 3x. 3 and 3x are not the same. Now just think, in place of x, whatever value you use, raised to the power 0 will be 1, right? Finally, it's going to be whatever value, 5 by 4, minus 6, 7, whatever value you give for x. Since x is raised to the power 0, the value of this one will be 1. So it is always going to be 3 into 1. So it's always going to be 3. It will not be 0 for any value of x. It will not be 0. 3 will not become 0 for any value of x. Please watch that. Since x is raised to the power 0, and we know that any value raised to the power 0 is 1. Anything to the power 0 is 1. So this value, so 3 is 3, x to the power 0, and whatever value you give for x to the power 0 is 1. So it's always going to be 3 into 1, which is 3. So this one is not going to be 0 for any value of x. 3 is 3 always. The constant polynomial 3 will always be 3. It cannot become 0 for some value of x. So that means there is no value for x. There is no value for x which can make 3x to the power 0, 0. So we say that a constant polynomial has no zeros. A constant polynomial has no zeros. How can it have zeros? 3 cannot become 0. A constant polynomial, the degree of a constant polynomial is 0. The degree of a constant polynomial is 0. A constant polynomial has no zeros. It has no zeros. Because whatever be the value of x, x to the power 0 is 1, 3 into 1 is 3. There is no value for x which can make 3 0. It is a constant. It cannot become 0. So a constant polynomial has no zeros. I'll write that. If you want to write something from the screen, just wait for 30 seconds.
Completed, ma'am. Completed, ma'am.
Yeah, so this is the conclusion. What's the conclusion? A constant polynomial has no zeros. Constant polynomial has no zeros.
Completed, ma'am.
Yeah. No. All right. A constant polynomial has no zeros. Now coming to a zero polynomial. Zero polynomial. We said that the degree of a zero polynomial is not defined because each one of us will write 0 in different ways. I'll say 0 x to the power 150. You will say 0 y to the power 1000. Somebody else is going to write 0 okay, z to the power 2. And in every case it is 0, the value is 0 because it is into 0. So in every case the value is 0. I'm repeating what we understood earlier. So for one, the degree is 150. For somebody, the degree is 1000. For somebody, the degree is 2. But the answer should be only one answer. Degree is only one answer. The degree cannot be many answers. So we say that the degree of a 0 polynomial is not defined. Is not defined. Now, how many zeros? The next question is, what we are currently discussing is, how many zeros does a 0 polynomial have? How many zeros does a 0 polynomial have? That's what is the current discussion. How many zeros? How many zeros does a 0 polynomial have? Now, when you take 0, when you treat 0 as 0x to the power, say 5, you give any value for x. You give any value for x. See, the degree should be one answer, but it can have any number of zeros. Like a linear polynomial, 1, quadratic maximum 2, cubic 3, biquadratic 4. So a polynomial can have any number of zeros. There can be a polynomial can have any number of zeros, but its degree should be only one answer. A polynomial can have any number of zeros. A linear polynomial has 1 0. Quadratic polynomial has maximum 2 zeros and so on. Number of zeros can be one or many. But the degree is only one answer. What is the degree of this polynomial? 1. What's the degree of this polynomial? 2. What's the degree of some other polynomial? 3. The degree should be only one answer. It can have any number of zeros. So the degree of a 0 polynomial is not defined because degree is only one answer. Degree is one answer and we cannot give one answer. So degree is not defined. But let's see how many zeros it has. How many zeros a 0 polynomial has? That can be many. All right. So a 0 polynomial. So since you can write 0 is 0x to the power 5, 0x to the power 5, whatever value you give for x. So supposing you give, minus 2. Okay, so to the power 5. So that's going to be 0 into minus 32, which is 0. Whatever value you give for x, ultimately it's going to be multiplied by 0. So the value is going to be 0, whatever value you give for x. Now 0 can be treated as 0 y to the power, say 200. Whatever value you give for y, negative, positive, fraction, whatever, an irrational value, whatever you give, and you take a long time and you find that y to the power 200, you say you find that value. Finally, into 0 is 0. Zero can be expressed in many ways. So if you treat 0 as 0, z to the power 3, you give any value for z you give. You give 0, you give minus 1, fraction, whatever value you give for z. Okay, some value you're giving for z to the power 3. And then with great difficulty, you're finding that value to the power 3, you're finding into that answer which you get. What is that answer into 0? Is 0. All your effort waste. Finally, answer is 0 only. So that means whatever real value you substitute in place of x or y or z, whatever real value you take in place of x, y, or z, whatever is a variable, the value of the polynomial is going to become 0. 0 is also a polynomial. The value of the polynomial is going to become 0. So we say that every real number is a 0 of the 0 polynomial. I told you, number of zeros can be many. Degree only one answer. You cannot say a 0 polynomial has many degrees. No. You cannot say that a 0 polynomial has many degrees. No. That's why we say the degree of a 0 polynomial is not defined. But how many zeros does it have? Every real value will make the value of the polynomial 0. So we say that every real number Every real number is a zero of the zero polynomial. Every real number, this is what you should write. Every real number is a zero of the zero polynomial, So, so last class, somebody was telling me, I think Sanjay and Sindhu, they at the end of the session, they were telling me that we'll be learning polynomials only in one variable. Yes, in your syllabus, we have polynomials only in one variable x, y, or z. That is what we will be seeing. You can give, when you're asked to give examples, you can give examples in many variables. But what you will mostly, 99% of the time, you will be seeing polynomials in only one variable x, y, or z. So just for your information. So we will be dealing mostly, most of the times, we'll be dealing with polynomials on only one variable, x, y, z, t, whatever. Is this clear, children?
Yes, ma'am.
So classification of, very good. Classification of polynomials based on the number of terms, classification of polynomials based on the degree, and then number of zeros of a polynomial. Number of zeros. The polynomial has only 1 0. It has 2 zeros, 3 zeros, 4 zeros, no zero. A zero, so a constant polynomial has no zeros. Because if the constant polynomial is 10, how can 10 become 0? You cannot give some value for the variable x, y, z and make 10 0, right? 10 is a constant and 10 will be 10 always. You cannot give some value for the variable x and make 10 0. So a constant polynomial, whatever is a constant, it will remain the same. If it's -5, it's going to be -5. So a constant polynomial has no zeros. The degree of a constant polynomial is 0 and it has no zeros. A zero polynomial, degree is not defined because it has so many degrees. It doesn't have a unique answer. One answer you cannot say. So its degree is not defined, but every real number is a zero of the zero polynomial. Because whatever value you give for the variable x, y, or z, ultimately into zero only. Ultimately, it's going to be into zero. So it will become zero. So every real number will make the value of the polynomial zero. Zero is always zero only. So every real number is a zero of the zero polynomial. So this, this introduction, Sanjay and Sindhu wanted it because they wanted it to be more clear. Yeah, is it fine now, children? For the class? So anything, see, when you watch the videos and you're kind of not satisfied with, meaning you want it to be more clear, you have some doubts, please request. You can send messages, you can call me. Please let me know. See, whatever help you need, kindly let me know. Is it fine, Sanjay and Sindhu?
Yes, ma'am.
You sure?
Yes, ma'am.
All of us understand?
Yes, ma'am.
I can
Yes,
see,
ma'am.
I can see Danya, I can see Tanishka, Nishant, Netra, Admita. Devadashni, are you there?
Yes, ma'am, I'm there.
Okay. Class, do we understand?
Yes, ma'am.
Okay. Sorry, children, just a minute. Yeah, children. So we'll continue with, we were working problems based on remainder and factor theorem. I think just let me know. I'll try to figure it out. Finished all this. Finished this. Yeah, yes, I should ask you about this also. Children, the other day I remember Devadarshini and Tanishka, you wanted the long division process, right? Division of polynomials. Yes, please unmute, Tanishka.
Yes.
No, did you watch the video which I had shared, and it was also explained in the lesson plans which I had shared with you. Division was explained there also, though it was of 8th standard. I had explained it in the videos, but I shared one 8th standard link where division of polynomials was explained. Tanishka, can I hear from you? Did you go through that video?
Yes, ma'am.
No, you'll have to be very honest if you understood or no.
Halfly I can understand, ma'am.
Oh, you're not still clear with it, is it? Or did you watch it clearly? Did you watch it fully?
Yes, ma'am.
What about Devadarshini?
Ma'am?
Yeah, did you watch the video link which I shared on
Yes,
division of polynomials?
Yes, ma'am, I did, ma'am.
Yeah.
But sometimes I'm forgetting the steps which we have to do, ma'am. So I'm rewatching it.
Did you work it out after watching the video? Did you work it out in your
Yes,
book?
ma'am, I did.
Okay. Okay, then in that case, I'll explain this division now. Wait. This is over, right, children? Did we finish this one?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, who can explain this one? Who can explain the division process in this? Nobody is ready?
Ma'am, can I try?
Madhumita, is it?
Yes, ma'am.
All right. Okay, now class, we'll just see how the division process, works. We'll understand this question, this one later. This we'll understand later. We'll just see the division here. How to perform the long division involving polynomials. Yes, Madhumita?
Ma'am, first, we're supposed to find out what we should multiply 4x to the power 4 with to get 4x to the power 4. So we
first,
want to.
yeah, let me just do it here. So this is the dividend, 4x to the power 4. 1 minute, just write down the dividend and divisor. I'll take a different slide. I'll work it there.
Yes, ma'am.
Kindly make a note of the dividend and divisor. Done?
1 minute, ma'am.
Yeah.
Done, ma'am.
Yeah. Yeah, tell me.
So first we are multiplying x square with
Oh, I need
4x.
the dividend. No, I need the dividend.
It's 4x to the power 4 plus 2x cubed minus 2x squared plus x minus 1.
No, plus 2x cubed.
Plus x minus 1, ma'am.
Minus 2x square.
Thank you, Danya. Minus 2x square. Four x to the power 4 plus 2x cubed minus 2x squared.
Plus x minus 1, ma'am.
Plus x minus 1. What about the divisor?
Ma'am, it's x square plus 2x minus 3.
X square minus 2x plus 3.
Plus 2x minus 3, ma'am.
Have I written it correctly?
Yes, ma'am.
Okay, so how do we initiate the division process? We need to divide first. The first thing is we need to arrange the terms in the descending order of the powers. Power 4, power 3, power 2, power 1, and then the constant. That's very important. We need to arrange the terms in the descending order of their powers. Here also in both the dividend and the divisor. In both the dividend and the divisor. So power 2, power 1, and constant. So first we need to divide 4x to the power 4 by x squared. What is the result?
4x power 4, ma'am.
All of us can participate. What's the result?
I mean 4x square, ma'am.
4x square.
4x square. Now we need to multiply this 4x. So that's the first term in the quotient. 4x square is the first term in the quotient. We need to multiply 4x squared with the divisor x squared plus 2x minus 3. We need to multiply that 4x squared. We need to first divide the first term of the dividend by the first term of the divisor. So that gives us 4x squared. Now we have to multiply 4x squared with the divisor x squared plus 2x minus 3. So what is 4x squared into x squared? 4x to the power 4.
Yeah.
4x squared into plus 2x plus 8x cubed. Yeah. And then this one minus 12
Minus 12x square.
x squared. This is what you should write here. Under this, write the result, write the product. Plus 8x cubed minus 12x squared. Next, what should we do?
Subtract.
Change the signs. Change the signs. Minus, this becomes minus, minus, and this becomes plus. Change the signs. 4x to the power 4 minus 4x to the power 4. 0. So they get cancelled. 2x cubed minus 8x cubed minus 6x cubed. Minus 2x squared plus 12x squared plus 10x squared. Sorry, 10x squared. Next what, children?
Plus x minus 1.
Yeah, bring the remaining terms down. Next step. We should find the second term in the quotient. So you need to divide. This is the new dividend. This is called the new dividend. This is the dividend. This is the new dividend. All right. So you need to divide the first term. Somebody's mic is unmuted. Tanya. So we need to divide the first term of the new dividend by the first term of the divisor. So it will be minus 6x cubed divided by x squared, which is minus 6x. Minus 6x. That's the second term in the quotient. Minus 6x is the second term in the quotient. Now we need to multiply minus 6x with the divisor. With the divisor, x squared plus 2x minus 3. So what do you get? Minus 6 into x squared, minus 6x cubed, minus 6x into plus 2x, minus 12x square. Okay, square. And minus 6x into minus 3. It will be plus 18x. Minus into minus plus. 6 3s are 18x. You need to write the product below here. Minus 6x cubed minus 12x squared plus 18x. Write the product, change the signs. Minus becomes plus, minus becomes plus, plus becomes minus. Minus 6x cubed plus 6x cubed, 0. Plus 10x squared plus 12x squared plus 22x squared. Plus 6 minus 18x minus 17x. And that minus 1 comes down. Now, Devadarshini, can you tell me the next step? Or Tanishka? Next step?
Ma'am, we have to divide.
We have to
22
change the signs, ma'am.
Ma'am, we have to divide 22x square by x square.
Okay. Then 22x square by x square. What do you get?
22, ma'am.
22. Yeah. So now you should multiply 22 with what? So 22 means plus 22. Write that in the quotient. 22 means plus 22. If you're getting simply 22, that means it's plus 22. Now you need to multiply 22 with the divisor.
2x.
X power 2 plus 2x minus 3, ma'am.
Yeah. Now what
And
is
we will
22
get
into x squared?
22x square, ma'am.
What is 22 into 2x?
44, ma'am. 44x.
Plus 44x. And what is 22 into minus 3?
Minus 66, ma'am.
Write out that here. So 22x squared plus 44x minus 66. What is the next step?
We have to change the sign, ma'am.
Yeah, plus becomes minus. You can put it in a bracket also. Plus becomes minus, minus becomes plus.
Plus.
Yeah. Now what is plus 22x squared minus 22x squared?
We have to cancel it, ma'am.
Cancel it.
Because it's 0, because the value is 0. Next, Tanishka or Devadarshini. Next.
Minus 61x.
Minus 3
Minus 61x.
x.
Plus 65, ma'am.
You understand the division now?
Yes. ma'am.
Yes.
Okay. So now this is the remainder because the degree of the divisor is 2. The degree of the divisor is 2. The degree of this, the degree of the remainder at this stage is 1. When the degree of the remainder goes less than the degree of the divisor, we need to stop the division process. Now here the degree is 2. Here the remainder at this stage, the new dividend, the remainder which is a new dividend, the degree is 2. The degree of the divisor is also 2. When the degree of the divisor is equal to the degree of the dividend, you should continue the division. When the degree of the dividend is equal to the degree of the divisor, these are the new dividends. These remainders are the new dividends. When the degree of the dividend is equal to the degree of the divisor, you should continue the division. Now here you see x is raised to the power 1, degree is 1. But in the divisor, x is raised to the power 2, the degree is 2. Remainder degree has gone less than the degree of the divisor. So the division ends here, which means this is the remainder. This is the remainder. That's a remainder. So now, if the question is what is to be subtracted, whatever is a remainder, whatever you get as a remainder, minus 61x plus 65 is to be subtracted. If the question is what is to be added, the negative of the remainder is to be added. That is, that this is the remainder, the negative of the remainder, that is 61x minus 65 is to be added. If the question is what is to be subtracted, Now you can clearly see that this dividend, that is this expression, this polynomial is not divisible by this polynomial. It's very clear because the remainder is not 0. The remainder is not 0. It's very clear that this biquadratic polynomial, excuse me, it's very clear that this biquadratic polynomial is not divisible by this quadratic polynomial because the remainder is not 0. So the question is, what is to be added? What is to be added to this, a biquadratic polynomial so that the resulting polynomial is exactly divisible. Divisible meaning exactly divisible by the divisor polynomial. So if it is what is to be subtracted, whatever is the remainder, this one is to be subtracted. What is to be added? The negative of the remainder. So you can see here the negative of the remainder. So when you apply the minus sign, it will become plus 61x minus 65 is to be added to f of x so that it is divisible by g of x. We finished this answer in the last class, right?
Yes, ma'am.
Yes, ma'am.
What about this?
Yes, ma'am.
We finished this also. Excuse me. You sure, children?
Yes, ma'am. We have to start from
Yes,
question
ma'am.
7.
What about this?
Ma'am, we have to do 11 sum.
8 we have to do, is it?
Ma'am, 8 also completed. 11 sum, ma'am.
Ma'am, we have to start from 11.
Oh, 11, huh? Oh my, okay. This one?
Yes, ma'am.
Yeah.
Yes, ma'am.
We'll just wind up today's session with this one. This is a simple question. Find the remainder. Find the remainder when p of x is divided by 2x minus 1. So when you're asked to find, listen to this, children. So when you're asked to find both the quotient and the remainder, you have to perform the long division. When you have to find both the quotient and the remainder, you have to perform the long division. If you have to find only the remainder, you can use the remainder theorem. Excuse me. I'll just get back, children. Just have some water and come back. Please try this. Yes, children. So I was telling you that if you have to find the quotient and the remainder, if you're asked to find both the quotient and the remainder, then you have to perform the long division. If you have to find both the quotient and the remainder, then you have to perform the long division. If you're asked to find only the remainder, you can use the remainder theorem. So how do we use the remainder theorem? Equate the divisor to 0. Equate the divisor to 0. So the divisor is 2x minus 1. Equate it to 0 and find the value of x. So x is equal to 1 by 2, or 2x is equal to 1. X is equal to 1 by 2. So now find p of 1 by 2. Find p of 1 by 2. Whatever is p of 1 by 2 is the remainder. Whatever is the value of p of x at x is equal to 1 by 2 is the remainder when p of x is divided by 2x minus 1. So when you actually perform the long division, when you perform this long division, whatever remainder you will get, the same thing you will get using the remainder theorem. This I've explained in one of the videos, right, children? I think I showed you the long division process. We saw the remainder there. And then we also checked it using the remainder theorem. Yes or no? In one of the YouTube videos?
Yes, ma'am.
Okay. Yeah, so when you divide 4x cubed minus 12x squared plus 11x minus 5 by 2x minus 1 using the long division, whatever remainder you will get, the same thing you can get using the remainder theorem in less time. So see here. So equate 2x minus 1 to 0. So you get x is equal to 1 by 2. You should find p of 1 by 2. It is not p of 1 by 2 is equal to 0. It's not that. You should find p of 1 by 2. When you're doing this, you're finding the value of this polynomial at x is equal to 1 by 2. P of 1 by 2 means you're finding the value of this polynomial at x is equal to 1 by 2. At x is equal to 1 by 2. And when you find the value of the polynomial at x is equal to 1 by 2, that is a remainder when this polynomial is divided by 2x minus 1. So you can go wrong in calculation here. You need to be very careful. So see here 4x cubed, 4 into 1 by 2 the whole cube, minus 12x squared, minus 12 into 1 by 2 whole square, plus 11x, plus 11 into half, minus 5 as it is, minus 5. 1 by 2 whole cubed. You cannot cancel. See, some of us will think you can cancel 2 ones or 2 twos. You cannot do that. 4 into 1 by 2 whole cubed. You must first perform 1 by 2 whole cubed. What is 1 by 2 whole cubed? 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 8. You cannot cancel 2 and 4. You cannot cancel 2 and 12. You have to first evaluate the powers. You'll have to first find the value of this one. Find the value of this one. See, here there is no power. Here, if possible, supposing this was 10, you can cancel. 2 ones or 2 fives are. You can cancel. Here, you cannot cancel 2 and 12. You cannot do this because it's 1 by 2 to the power 2. So write 4 as it is. 1 by 2 the whole cube, which is 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8. 1 by 8. So you can see it here into 1 by 8 minus 12 into 1 by 4, because 1 by 2 into 1 by 2 is 1 by 4. Then this one, 11 into 1 is 11, 11 by 2. 11 into 1, 11, 11 by 2. When you multiply these two, you will get 11 by 2, minus 5. Minus 5. Now you can simplify within the bracket. 4 ones are, 4 twos are. So 1 by 2. 4 ones are, 4 threes are. So minus 3 plus 11 by 2 minus 5. then you take the LCM and all that, and LCM you don't have to take here, I think, because what is -5 minus 3, children? -8. And what is 11 by 2 plus 1 by 2? 12 by 2, which is 6. See these two. 11 by 2 plus 1 by 2 is 12 by 2, which is 6. This one and this one is 12 by 2, which is 6. -3 minus 5 is -8. So it is 6 minus 8, which is -2. Which is -2. So when you perform the long division, the remainder is -2. When you divide this by this using the long division, you'll get some quotient. That quotient you cannot find using remainder theorem. The remainder you can find, which is -2. If you have to find the quotient, you have to use the long division. Have you learned synthetic division in school, children?
Yes, ma'am.
Yeah, we'll see synthetic division in the next class. So 1 mark. If you have to answer objective questions, you can use synthetic division to find the quotient quickly. How many of you have learned synthetic division? Netra?
No, ma'am.
Devdarshini?
No, ma'am.
Tanishka?
Yes.
Yes. Sindhu and Sanjay? Okay. It's a very simple thing. We'll see that in the next class. So if you have to answer objective questions, you can use a synthetic division. Otherwise, it's not a part of our syllabus. So we cannot use it otherwise. For 2-3 marks questions, you cannot use synthetic division. I'll tell you when you can use it. 1 mark question where steps need not be shown. Or to verify our answer, we can. It'll be nice to know the concept of synthetic division. We'll see that in the next class. Yes, children, take this as homework. It's time. This one alone.
We already completed this.
No. Did we finish this, children? Was it homework, Devadarshini?
One sec, ma'am.
No, ma'am, we didn't complete this.
Okay, so let this is homework. Finish this by tomorrow.
Sorry, ma'am.
Finish
Sorry,
class.
it's not. I thought we
Fine.
completed the 12th questions also.
Okay, okay. Maybe you saw the question number and not the question.
Yes,
Maybe.
ma'am.
Yeah, okay. So find the quotient and remainder. So you should use a long division. Use a long division. We'll see the answer tomorrow. All right, children. Class, use the emoji. Raise your hand. Are you there, Raja? Raja, are you there? Okay, so Sanjay, Sindhu, Madhumita, Devadarshini, Netra, Dhanya, Tanishka, Lishant, Srijana. Raja, are you there? Okay. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you,
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you.